Day 600 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3074, Apple redistribution into boxes. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array apple of size n and an array capacity of size m. There are n packs where the ith pack contains apple of I apples. There are m boxes as well, and the ith box has a capacity of I apples. Return the minimum number of boxes you need to select to redistribute these n packs of apples into boxes. Note that apples from the same pack can be distributed into different boxes. All right, y'all, so that sounds pretty simple at first, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input apple equals an array of integers 1, 3, and 2. Capacity equals an array of integers 4, 3, 1, 5, and 2. The output is 2. The explanation says we will use boxes with capacities 4 and 5. It is possible to distribute the apples as the total capacity is greater than or equal to the total number of apples. So in this case, you can see we have a total of 6 apples, right? We have a box that has 1 apple, we have a box that has 3 apples, and we have a box that has 2 apples. What we want to do is find the minimum number of boxes that we will need to select to redistribute these apples into boxes, right? In capacity, this shows how many apples each box can hold. So this box can hold 4 apples, this box can hold 3 apples, this box can hold 1 apple, this, and so on, right? So we have 6 apples, right? And we need to place these 6 apples in the boxes, and we want to return the minimum number of boxes, right? So in this example, they use 4 and 5, right? So in this case, they could use the box, this box right here has 4, right? So we could put 4 apples in this box, or we could put this box of apples that has 3 apples in this box, and we'll still have 1 left over. Then we could add this apple, and then we could this box will be full, right? So say if we put these 4 apples in this box that can hold 4 apples, this box would be full, but we still have 2 apples left. Now we could put those 2 apples in this box, or this box. In the example, they say we're going to put it in this box. So that is how the question works, right? After we put these 2 apples in this box and we put these 4 apples in this box, then all of the apples are in a box. And in total, we could do that in 2 boxes, right? Because we want the minimum. So we could also have done it like this, use these 2 boxes in this box, but that would have took 3 boxes. We want the minimum. We were able to do it in 2 boxes with this box and this box. So just in case that didn't make sense, let's take a look at example 2. So in example 2, we have our input apple equals an array of integers 5, 5, 5. Capacity is an array of integers 2, 4, 2, 7. This time the output is 4. It says we will need to use all of the boxes. So in this case, as you can see, we have 15 apples right here. In the box the box can hold 16 apples. Or these boxes, we have enough boxes to hold 16 apples, right? So it says right here, apples from the same pack can be distributed into different boxes. So we just need to figure out how to get these 15 boxes, or these 15 apples, into these boxes that have a maximum capacity of 16 apples. In that case, we will need to use all 4 of these boxes. So that's why the output is 4. Now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, the first thing we're going to do is we're going to calculate the total number of apples by summing up all elements in the apple array. So to do that, we could just come right here, declare a variable called apples remaining, and we could set that equal to apple dot reduce, open up the parentheses, say 0, comma, plus. And what this is going to do is it's going to start the count from 0, and it's going to add up every element in apple. Boom. Then we need a counter to track how many boxes are used to store the apples. So we could just declare a variable called boxes used, and we can set that equal to 0. Boom. Now we need to sort box capacities in ascending order, then reverse to iterate from the largest to smallest. So we're going to say for box and capacity dot sorted, put the parentheses, dot reversed, put the parentheses. We're going to open up the brackets, and if all apples have already been placed in the boxes, we're going to stop early. So we're going to say if apples remaining is less than or equal to 0, then we can open up the brackets and we can break. Boom. Now we're going to use one box. So we'll come underneath this. We'll say boxes, boxes used plus equals 1. Boom. Now we're going to subtract this box's capacity from the remaining apples by saying apples remaining minus equals box. Boom. Now we need to return the minimum number of boxes required to store all apples by coming right here. And we could just say return boxes used. Boom, just like that, y'all. So let's give this a run. Make sure it runs correctly before we submit it. And look at that, y'all. It's accepted. So now let's submit it. Make sure it still runs properly, because we all know how LeetCode can be. And look at that, y'all. 2 milliseconds beats %% of users. Not too bad. I don't know what that dash means, but I'll take it, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.